Hello friends, in this video I will discuss about one more problem given in GATE 2020 in ECE stream in communication systems, and the topic of interest is probability and random variables. The question goes like this: a fair coin has two sides labeled as 0 and 1. Okay, and this coin is tossed two times, and we denote the values m and n to be the labels corresponding to these outcomes. So, and we define a random variable x to be minimum of these two terms m and n. So we are asked to evaluate the mean of this random variable x. So let us see the mapping diagram. So because a coin is tossed twice, so we will have the four possible outcomes, which are 0 0 0 1 1 0 and 1 1. Okay, so but we are defined a new we are given a random variable x to be minimum of m and n. So for the first case 0 0, minimum of 0 0 is again 0, and hence random variable x will map 0 0 to 0, and also 0 1 to 0, and also 1 0 to 0, because minimum of all the three cases is 0. But if you look at the last case, which is 1 1, because both are ones, the minimum of 1 and 1 is 1. And we can easily see that the CDF of this random variable x is given to be a staircase structure, because x is a discrete random variable. So if you differentiate the CDF, we get the PDF, which is of this form. Why? Because wherever there is discontinuity, we have to replace that with a Dirac delta function, and the strength of Dirac delta function is equal to the amount of discontinuity. So at 0 we have a discontinuity of 3 by 4, and hence strength of Dirac delta at origin is 3 by 4. Similarly at 1 we have the amount of discontinuity to be 1 by 4, and hence the strength of this Dirac delta is 1 by 4. Okay, so we can write the PDF mathematically or algebraically like this, which is small fx of x is 3 by 4 times delta of x plus 1 by 4 times delta of x minus 1, and hence the mean of the random variable x is given by expectation of capital X, which is equal to integral minus infinity to infinity x into small fx of x dx. Note that this is just the definition of the mean of x. So by replacing the small fx of x with what we have got before, so we get integral minus infinity to infinity x whole multiplied with 3 by 4 times delta of x plus 1 by 4 times delta of x minus 1 dx. So by expanding we get 3 by 4 integral minus infinity to infinity x delta of x dx plus 1 by 4 x delta of x minus 1 dx. So we use the definition of Dirac delta function, which is integral minus infinity to infinity phi of x delta of x minus x naught dx is phi of x naught. So if you look at the first case, phi of x is x and x naught is 0, and hence the first integral would be equal to 0, and by using the same property second integral turns out to be 1, and hence finally we get 0, expectation of x to be 0 plus 1 by 4, which is equal to 1 by 4. So hope you have understood this problem. Thank you.